Well, hello and welcome back. In this video segment, we're going to talk about multi-threaded programs in Java. So let's jump in theoretically to what the issue is. It's really, you want your program, your computer, to be doing more than one thing at a time, and there's two different ways of doing that that are quite distinct from each other. One that you're very familiar with, if you run lots of different programs at the same time, you have Eclipse and Word and a web browser and all of these things running at the same time. These are processes, and you could think of your operating system as doing multiple processes at the same time. This is not the same as multiple threads, and there is the issue of inter-process communication, or IPCs, that would allow running applications to talk to each other. But that's not what we're talking about today. We're going to talk about using threads within a single process. So the process is one instance of the Java virtual machine, and we would have multiple flows of control within that one process, and that's what we're going to learn how to do. So there's lots of reasons it's not as easy as a single thread. So there has to be reasons to do something if it's not as easy as the other way. The reasons you would want to do it, if you have a program that's busy, it's waiting for something, that's two different things. If you have a thread, a Java program that's waiting for something, that means that it's not busy, and it is sitting there preventing any other work from happening. So if we had another flow of control, we could say, okay, you go and use the processor for a while I'm sitting here waiting for something to happen. So efficient use of the processor is the first reason. The second reason you might want to write a multi-threaded program is that some problems are naturally described this way. So it's easier to implement a simulation of some things that go on in the real world by using multiple independent flows of control, or multiple flows of control that talk to each other or share data among each other. And the easy to get a hold of example that a lot of people use is the multiple bank tellers who are working independently of each other. And you have this problem: the bank wants to know how many tellers should you have if 4 customers are arriving every 5 minutes, and on average it takes a bank teller 7 minutes to deal with each customer. Well, instead of doing it mathematically, it might be worth it to write a program that simulates this, and then you can do a what-if analysis. Well, let's add 3 more tellers and see if the wait time of the customer goes down in a sufficient amount. And so some problems are just naturally described with multiple flows of control. And the other one that's relatively new, we have now multiple cores, which is really like in our processor chip there are multiple processors. And when dual-core processors happened, that was really exciting, and now 16-core processors are on their way, and we don't have really good ways of programming to take advantage of this computational power that's provided by these multi-core processors. And one of the ways of doing that is to allow threads to execute on different cores, different processors. Well, we're going to jump right in and start coding, and right from the beginning look at how you would implement threads in a Java program. The first thing to say is that there is a thread class provided for you, and that's the one that we're going to use. If you inherit from the thread class, you have created something, a class that is a thread. And if you create an object that is a thread, then you have a thread, and it has a flow of control. So that part is really not too hard. When you have a class that has a main method in it, we easily understand that that's the beginning of a flow of control. And a thread, or something that is a thread, has a run method in it. And that's kind of the equivalent of the main method. So this is one way of making a thread. You can inherit from the thread class. And the other way is to create an instance of the thread class and pass in the behavior that you want the thread to have. This is a little bit harder to describe than it is to just show you in code. I mean, it's really easy in code. So I think what we need to do is to jump in and start writing some code to see how threads work, and just make it incrementally more interesting as we go along looking at the code. So let's go and do that now. Well, we've been using threads in Java from the beginning, whether we knew it or not. So I made a very simple Java program, kind of the Hello World Java program to get us started. And I made an object of type scanner, and I input anything. So think about what happens when we run this. We're running on the main thread. So there is a thread, the main thread, and we created a scanner, and we output enter anything, and we stopped right here. So here's the problem. This main thread is stopped, and nobody else can do anything until this thread has satisfied its input request. So we can see that the program is still running, but nobody else can do anything, and that's kind of bad. So when we enter anything, then this main thread can continue, and the program has terminated. Well, let's put an output statement here just to make that explicit. The input request was satisfied, S-A-T-I-S. So right now the program is wait blocked. It is input blocked is what I should have said. It is input blocked, and when we satisfy that input request, then the thread can continue. So we haven't done anything special so far to create any new threads. We're just using the thread that we've had all along. Let's do something else while we're here, just to kind of set the stage. In the thread class, there is a method called sleep. And we use this quite a bit when we're talking about threads, because it's a good way to demonstrate the behavior of the threads. The sleep method requires that it be in a try block. So the sleep method throws an exception, and we can ask Eclipse to just put in the try catch block. So this block of code, Control D will delete a line if that helps you. So this is a length of time that the thread will stop, and it's in milliseconds, so that's the equivalent of 3 seconds. So after we do this output statement here, we're going to go to sleep for 3 seconds, and then we're going to say I slept for 3 seconds. So let's run that and think about what the thread is doing. Right now the thread is input blocked. We're on this line of code right here, the next, and nothing is happening because we're input blocked. So whenever we enter something and unblock, the request was satisfied, and then we go to sleep. And you notice that this second output statement, I slept for 3 seconds, will come up eventually, and we can make that a little faster. Let's watch it with 2 seconds and see what happens. So we enter something, Now the thread is asleep, and I changed it to 2 seconds, and of course didn't change the message that it was sleeping for 2 seconds. Okay, and when the main method is over, you might guess that the main thread is over. So the behavior of the thread in this case is what's in the main method, and if the main method ends, then that thread is said to go to a dead state. So we're going to use some analogies with life and death and life cycles of threads to help understand what's going on among the threads. So that's the first start. We're talking about what's going on in the main thread, which we've been using all the time. Okay, well let's make a thread. In the default package we're going to make a new class, and this class will be called Fortune. You'll see why after a little bit. And let's go in here, Control D, to clean this up a little bit. And we're going to say that this class extends thread. And oh, I left the main method in there. I didn't mean to do that. Okay, so in the thread class there is a method called run, and we're going to override that method. So public void run with no parameters. It couldn't be simpler. It doesn't return anything, and it doesn't take any parameters. So let's make a very simple behavior for this thread. So let's say while true, that's gonna go for a long time because true will be true for a very long time. I can't type today. Okay. So it's just going to, for a long time, say good things will come your way. So that's your fortune cookie. So that's it. This is the simplest possible thread. And if we make an instance of this class, we have created something that is a thread. It inherits from thread. So let's go over here, and somewhere at the beginning we're going to say let's make an object of type fortune. So it's the expected way that you make an instance of a class. So this class doesn't have anything special about it. It's a regular Java class, except that it inherits from this thread class. So it is a thread. And we're not going to call the run method. We're going to call the start method. And how do you spell fortune? That doesn't feel right. Should there be an E at the end of it? I don't much care. So let's say my fortune, spelled right or wrong, and we're going to call the start method. The start method is inherited from the thread class. So we inherited some methods, not too many, from the thread class. One of them is start. And if we start this thread, we say that we have spun a thread. We have spun a thread, and now we have 2 threads. So let's run this and just see what happens. And oh, look at this. Good things will come your way is happening over and over and over. Well, what's happened to the main thread? The main thread, I think we probably missed it, said enter anything and then it is blocked. And that gave the fortune thread the right to use the processor without any competition, because this particular thread is wait blocked. No, I keep saying that wrong. It's not wait blocked, it's input blocked. So if I go down into the console and hit enter, No, actually I have to type some characters and hit enter. Did that allow the... Well, it's kind of hard to see what's going on, isn't it? Let's kill this and let's go into our fortune class, and every time we say good things will come your way, we're going to sleep for 5 seconds, and maybe that will allow us to see what's going on better. And remember that we have to put a try-catch around that sleep. So we're going to spit out a fortune and then go to sleep for 5 seconds, and then on the next iteration spit out a fortune again. See if that makes this any easier to see what's going on. Okay, so the main thread has said enter anything, and so we started the fortune thread, and when the fortune thread went to sleep, well, we'll talk about exactly who gets the processor at what time. The main thread is blocked, input blocked, and the fortune thread continues to execute, sleeping 5 seconds every time that it... So we typed something to the main thread that was waiting for the input, and now see what happened. The main thread output, the input request was satisfied. The fortune thread is still happening. The main thread slept for 2 seconds. So we have 2 threads, 2 flows of control happening in parallel with each other. And now we have to try to figure out, well, who gets the processor when? And what's going on? How can we study these threads? This is the simplest possible case, and it's already not so easy to understand who gets the processor when. And we need a map to understand the states of the thread. What's going on with these threads? So I need to show you a picture. Let's go over here. Okay, the life cycle of a thread. The born state of a thread is when we have an object of type thread and it's ready to be started. And how do we get from the born state to the ready state? We call the start method. So this is a state diagram. We have an object that is a thread, but it hasn't been started yet. So that thread, the fortune thread, is in this state. And then when we start it, it's ready to run. That doesn't mean that it gets the processor right away. It means that it's ready to get the processor. And how do you get the processor? How do you start executing the run method in that thread? Somebody decides to dispatch your thread to a processor. Let's assume we have one processor, to the processor. And then you're in a running state. If you're in a running state, then you are executing your main method or your run method. Okay, so here are the states that we understand so far. The born state is when we have an object of type thread that hasn't yet been started. And when it does get started, when we call the start method, it goes to the ready state. That means that the dispatcher can give it the processor and it can go to the running state. Look at all the different ways there are to leave the running state. You give up the processor when you go to sleep. And while you're asleep, you're in the sleeping state. That's one way of giving up the processor to another thread. Another way of giving up the processor is to issue an I/O request. So the main thread asks the user to enter something, and that thread becomes I/O blocked. So how do you get out of the sleeping state? Well, the sleep time expires. the 3 seconds or 5 seconds or whatever it is, and then you go back to the ready state. From the ready state, the dispatcher decides that you can get the processor. How about the I/O request? If your I/O blocked, how do you get the processor back? Well, when the I/O process is satisfied, the input usually is satisfied, then you go back to the ready state and the dispatcher can give you back the processor at some time. So we're starting to understand the life cycle of the thread by using this state diagram. We'll come back to this. So let's talk about the states of the threads in terms of the code. Remember, on this line we made an instance of something that is a thread. So after this line executes, we have a thread that's in the born state. It hasn't yet been started, it's born, and the start method is the event that causes that thread to go from the born state to the ready state. So the ready state means that your thread can be assigned a processor. Assume we have only one, and we'll say that the thread can have the processor. Why would we call the start method instead of the run method? There's nothing special about this run method. It's just a public method that returns nothing and takes nothing. We could call the run method. Why not just call the run method directly? Well, we would be executing the run method on the main thread. So just as you call any other method, if you call the run method, you haven't started a competing thread, a thread that competes for the processor. So although it's possible, the general rule is you don't ever call the run method. You call the start method. Oops, what did I just do? That's okay, we're not going to keep that line anyway. We will call the start method and put that thread into a ready state so that the dispatcher can give it a processor. Okay, so what happened here on the main thread when we executed an input statement? The main thread went to the state of I/O blocked. And that means that as of right there, this thread is not eligible for the processor. It cannot get to the running state. Sorry, it cannot get to the ready state until that input request is satisfied. So then when it is satisfied, the processor, the main thread, goes back to the ready state and the dispatcher can give it the processor. When we call the sleep method on the main thread, that means that this thread went to the sleep state and it cannot get back to the ready state until this amount of time, 2 seconds, has expired. When that time expires, this thread, it doesn't go to the running state, it goes to the ready state. And the ready state means that the thread can be dispatched to a processor. So sometime after 2 seconds, this thread will get the processor back again. Not at exactly 2 seconds. At exactly 2 seconds, it goes to the ready state. And then when the dispatcher decides that it gets the processor, that's when this thread can go to the running state. The fortune thread is kind of easier. It only has 2 states. It's either asleep or it's, I guess there's 3 states. It's asleep, or it's ready, or it's running. This figure is really a useful way of understanding the states of the thread, and there's not really that many. When it's born, The event that gets it to a ready state is the start method. When it's ready, the event that gets it to running on a processor is that it gets dispatched there, and we will talk about what that means. When you go to sleep, you're in the sleeping state. When the time expires, you go back to the ready state, ready to be given the processor again. And when you are I/O blocked, the only way to get out of this blocked state is that that I/O request is satisfied, and that puts you back into the ready state. Okay, so there are a few more on this, but what we need to understand next is, what does it mean to dispatch a thread to the processor, and who does that? What is that process looking like? So let's go to another slide and talk about that. So there's good news and bad news in here when we talk about the thread dispatcher or the thread scheduler. Some people prefer to call it a scheduler. So the question is, what happens when there are multiple threads in the ready state? Who gets the processor? And the good news is that as the programmer, it's not up to you. You don't really have control over this. You can work with how the scheduling algorithm works, but let's look at it. The first way, there are two different ways. This is the bad news. There are two possible ways that the scheduler is working. One is called round robin or time slicing, and that means that all threads are treated equally, and each thread is given a time slice on the processor, and when that time expires, it gives up the processor, and the scheduler puts the next thread in order on that processor. So time slicing is very equitable, and it's quite easy to work with. You just make a bunch of threads and you throw them all in there, and they all get some time to execute, and it looks like they're all doing stuff at the same time. So time slicing is the easy one for the programmers, but it gives the programmers less control. So let's talk about priority preemption. The concept here is that some threads are more important than others. So the work of some threads, you really want that to happen right away. As soon as there's work to be done, do that work, regardless of who else is waiting. So in priority preemption, the threads have a priority. And when a high priority thread is ready, in the ready state, then it will get the processor preempting other threads that may be ready or running. So when a high priority thread is ready to run, the scheduler will take the other thread out of running and move this high priority thread to the front of the ready state so that it will get the processor more quickly. These are quite different behaviors. So here's the really bad news. As the Java programmer writing a multi-threaded program, which of these scheduling algorithms are going to be used? The bad news is Java uses the underlying scheduling algorithm of the operating system. So this is the first time in your study of Java where one piece of Java code runs differently on two different machines. And we know for sure that the underlying scheduling algorithm on a Microsoft Windows box is round robin. And the underlying scheduling algorithm on a Unix box is priority preemption. You might know that a Macintosh uses a Linux underlying operating system, underlying its Lion or Wildcat or whatever it is currently. So you're going to have a different behavior in your multi-threaded programs depending on the underlying operating system. That's very bad, because the write once run anywhere, which we've come to understand, is not true in multi-threaded programs. So we have to now be careful that when we throw a bunch of threads into the mix, that they are going to behave in an acceptable way with different scheduling algorithms in the underlying system. Okay, let's go back now and make our multi-threaded program just a little bit more interesting. Well, there's a couple of miscellaneous concepts that I would like us to look at before we make the thread class that we created any more complicated. So remember the fortune class when we, I'm going to make that go a little faster. 1 second instead of 5 seconds so that the behavior is a little bit easier. So we have two threads, the main thread and the fortune class, and when we run this, the fortune class is executing and giving up the processor when it goes to sleep, and the main thread is I/O blocked, and when we type something at the main thread, the input request was satisfied, the main thread went to sleep. I don't know why, just for demonstration. And what happened here? Well, this is the end of the main method. When the main method is over, or the run method is over, the thread goes to a dead state, and it cannot be restarted again. There is no restart method. You could make a new instance and call the start method again, but the object that is a thread is only used once. So our main thread is finished, but the thread that we spun is still running. So that's a specific kind of a thread. There are two kinds of threads in this respect. One thread will keep running when the thread that created it is dead, and the other thread will die when the thread that created it dies. So these are called user threads and daemon threads. Let's kill this. So I'm going to say that before we start it, my fortune thread, there is a method that we inherit from the thread class called setDaemon. Okay, so if it's a daemon thread, it only makes sense that it will keep running so long as the thread that created it is alive. So a daemon, it depends on how old you are, how long you've been in computing. A daemon thread used to be a thread that, a process that runs around and makes sure that things are working, and on old computers. And if the thing that it's looking at doesn't exist anymore, it doesn't make sense for it to be there. So let's see if we have changed the behavior. We're going to put something in here so that the main thread will stop, and lo and behold, the thread that we spun has also stopped. So when the main thread died, went to a dead state, the thread that we spun also went to a dead state because it is a daemon thread. Okay, so the main thread can create threads, and those threads can create threads, and those threads can create threads. A lot of people call this spinning threads. And if your thread creates daemon threads, then it can only create daemon threads. If your thread creates user threads, then it can only create user threads. But that doesn't mean that one of the threads that you've spun can't create threads of the other type. Okay, so a daemon for a user thread. Why did they call it user threads? These don't seem to be opposites at all. If we set this to false, that means that the thread that we spun is not associated with the life of the parent thread, the thread that it spun. So now we have something called a user thread. My fortune thread is a user thread. It will continue to run after the main thread has gone to a dead state. Okay, the reason that they call these user threads is because when you go to a website, suppose you're going to buy some tickets for the basketball game, and you go to the website, it's likely that what will happen is that the website will spin a thread to talk to you. And then someone else goes to the same website to buy their basketball tickets, and the website, the Java program on the website, will spin a thread to talk to that user. Get it? So these user threads, they finish when the interaction with the user is done. They aren't dependent on the parent thread. So they will go away when the interaction with the user is done, once you've entered your credit card number and all of your personal details and your driver's license and social security number. I'm just kidding. Don't do that. The user thread, that's why they call it a user thread. It's not dependent on the life of the thread that spun it. But a daemon thread is. Okay, now let's go and do something more interesting with our thread class. Well, I decided to keep things kind of simple, so I made a new class called Fortune Cookie, and I kept the old one called Fortune, and I just copied the run method from the Fortune class in here. So I'll put this back, extends thread, and we're going to make this class a little bit more interesting. So classes can have instance variables and including threads. So I'm going to say that we have two instance variables, and then let's make a constructor method for Fortune Cookie. And we're going to have the user can pass in the first part of the fortune and the second part of the fortune, and then let's make a sleepy time. How much time will this sleep? So we're going to make this run method a little bit easier, more interesting anyway. So the user who makes an instance of this thread will now have to pass in some information. So this dot first gets first that was passed in, this dot last and this dot sleepy time gets sleepy time. Control space will help you. Will help you go a little bit faster. Well, we really should put accessors and mutators for these instance variables, because I will frown at you if you don't, so I better do it myself. We can ask Eclipse to do that for us, generate the getters and setters for first, last, and sleepy time, just in case we want to change those. And I'm going to put those down at the bottom, well, at least below the constructor. I'll put them even below the run method because I'm kind of just doing that for completeness. Okay, so this time in the run method, we're going to print out the first part, and then we're going to go to sleep for some length of time. We're going to go to sleep for sleepy time. And then we're going to output the last part. What have I done here? No clues. No clues. Syntax error. Oh, one too many. Okay, I hope you're seeing that quicker than I am. Okay, so we have a slightly different behavior. We have a class that is a thread, and it has some instance variables in the usual way, and the behavior is going to be that we print out the one instance variable and then we print out the other instance variable. So let's go and make some fortune cookies. This makes it more interesting to let's just get rid of that for now. We're going to make some fortune cookies. New fortune cookie. You will always, I'm making this up, I don't know if it's going to make sense. And then the last part is travel to interesting places. And then the sleepy time, I'm just going to pass in a second. Let's make another fortune cookie. Come on. This one will start, never expect lots of money to come to you. And it will sleep for slightly longer than that. Okay, so we have two threads in a born state. They don't do anything yet. They just exist as objects in the born state. And I'm going to go back over here into the run method, and instead of print line, I'm going to do print for the first part, and I'm kind of anxious to see what this is going to do because I didn't rehearse it, but it might do something fun. Let's go and say cookie 1, cookie 1 start, cookie 2, do you think will happen? So we have 3 threads now. 2 of them are instances of the same class, and the main thread will stop here, and we'll watch the behavior of the 2 fortune cookie classes. Okay, you will always lots of money come to you. Never expect travel to interesting places. Never expect... So the point here is... So sometimes we're getting, you will always lots of money to come to you, and sometimes we're getting, you will always travel to interesting places. So these multiple threads are competing for the processor, and based on the behavior of the run method, they are coming up with things that are kind of difficult to interpret because we're mixing in the output. So this was just intended to be a fun example of seeing how multiple threads compete for the processor. And when it gets complicated, when there are lots of threads with lots of different behaviors, then we have a problem. What's the problem? Well, how do you debug your Java programs when they don't do what you expect them to do? You set breakpoints. So how would we set a breakpoint in a multi-threaded program? Well, we could set a breakpoint here, and that wouldn't gain us very much because this thread is going to stop on this line anyway. And those other threads are not impacted by that breakpoint. So let's go in here. Let's set a breakpoint here, and then run it in the debugger. It should tell us that it will switch to the debug perspective. Well, we hit a breakpoint here, and oh, now for the first time in your debugging of Java programs, this window is interesting. So the main thread has hit a breakpoint at line 25, and the thread 0, we didn't give it a name. We could have given it a name. The default name is thread 0. It's hit a breakpoint at line 16. Here it is at line 16. And this thread has hit a breakpoint at line 16. It's the same breakpoint. What I'm hoping that you're going to understand from all of this is that debugging multi-threaded programs is not quite as easy as debugging single-thread programs. So if we hit resume here, what will happen? Yeah, I don't even really know. Let's turn that breakpoint off and hit resume. Okay, let's go to select the main thread and resume that one. Enter anything. So the walking through buttons the stepping of stepping through code is going to depend on which thread do you want to step through. And that's different from what we've had before. Isn't this interesting? The main thread is gone, but we still have two threads called thread 0 and thread 1, kind of unfortunately, that we can keep executing in the debugger. And the dogs don't like this either, and I don't really have time to edit this, but walking through, one issue that we kind of alluded to right at the beginning was that there are two ways of making a thread. One is to extend the thread class, and there is a different one. Well, the disadvantage of extending the thread class is that you can only extend one class in Java, and perhaps you want to extend something else. That's fairly common. Suppose we were making a really complicated multi-threaded program that had lots and lots of bank tellers. That example keeps coming up. You might want the bank teller to inherit from a person class or something like that. And then you couldn't have a multi-threaded behavior as part of that. So instead of extending the thread class, we're going to do something different. We're going to implement an interface. So Runnable, did I spell it wrong? There. Runnable is an interface which is as simple as it could possibly be. It has this method in it only that you override, so a public void run. So what we're really saying by implementing Runnable is that a fortune cookie, something that is a fortune cookie object, is a runnable, meaning it has a run method. So let's save that, and now when we go back to make our instances of fortune cookie, instead of saying we're going to make instances of fortune cookie, which is a thread, the way we had it before, we're going to make instances of thread. So let's call cookie 1 a new thread, and we're going to pass in an instance of runnable, something that is runnable. Well, look at this. There's the creation of an object that is runnable, implements runnable. I'm going to copy that, and I'm going to do two things at once. I'm going to make the runnable object, and I'm going to pass it to the constructor of the thread class. Does that make sense? We have to do the same thing for cookie 2. Fortune cookies do not come from China. Fortune cookies are an American invention that we have decided are part of Chinese culture, but they are not. Okay, so there we have achieved the same thing now. We had in the previous one we had an instance of a thread by virtue of making something that is a thread. And in this example we have made an instance of thread and we have passed in a runnable. Those are the two ways of creating a thread that you can then start. So well, let's run this and make sure that we haven't done anything wrong. Have we done something wrong? Well, this odd behavior, which is not too interesting, but it is multi-threaded behavior. Okay, before we leave this, I want to just look at a couple of methods that are in the thread class So if we look at, there is a method called join. The join method takes away from the doing things in parallel. So the whole idea of writing multi-threaded programs is that they would run kind of at the same time. And if you join two threads, you're saying that you want to wait until that thread finishes. Oops, what did I do there? I'm thinking and typing at the same time. Control D. Okay, so if we say cookie1 join, okay, cookie1 join, and this is a little bit confusing sometimes, and I often have to look this up. Who is waiting for who to finish? Okay, so every line of code executes on some thread or other, and this line of code executes on the main thread. So what we're saying is, from the perspective of the main thread will wait for cookie1 to finish. So that's not too interesting in this case, because cookie1 and cookie2 are not the ones that stop and wait. The main thread is the one that's waiting. The main thread is waiting for cookie1 to finish. Cookie1 is not going to finish because it has an infinite loop in it. So we never got to the line that said enter anything. So the main thread is joined. It is executing only after this line based on whether the cookie1 has finished, and cookie1 has not finished, so we did not get further on the main thread. So joining one thread from another very often means that you've created something that's too complicated to understand when it's all running in parallel, and then you try and unparallel it by saying, I'm going to join one thread to the other and just let one finish its work and before the other one starts. So I don't know. There are some reasons for joining threads. Most of the time joining threads is an admission that you have something too complicated to deal with. Okay, let's look at cookie1 set priority. And remember that in a priority preemption scheduling algorithm, this is important. And there are some defined constants in the thread class. I'm pretty sure that min priority is 1 and max priority is 10. Yes, min priority is 1, max priority is 10. The normal priority, the default priority, is 5. So threads can have a priority from 1 to 10 with a default of 5. And for our case, since I'm working on a PC, a Windows-based PC, saying that 1 has a higher priority than 2 has no impact, because we're using a time slicing scheduling algorithm. Well, I want to add something in here. This is kind of an advanced topic, but let's just throw one in here anyway. Let's say I'm going to do all of this in one step. I'm going to say new thread. So there's a call to the constructor of the thread class that will create a thread object that I can start. So I'm going to do this all at once. I'm going to make a thread object that has a very simple behavior, and I'm going to start it. Okay, so what will I pass to the constructor of the thread? I need to pass a class that implements Runnable. Okay, so you haven't seen this before probably. I'm going to make an anonymous inner class all at once by saying new Runnable. Oops. Okay. So, what do we have to do to implement the Runnable interface? We have to make a run method. What does this run method do? Well, whatever we want. Not too much. I didn't put a loop in there. Let's format this. See what Control-Shift-F will format things for you in Eclipse. Control-Shift-F. Control-Shift-F. One is the easy way to read, and one is the correct way of formatting. So the easy way of reading, since this is the first time we have seen an anonymous inner class, what is this doing? What is this doing? Okay, so from there to there, the part that's highlighted, we defined a new class. This new class implements the Runnable interface. It makes an instance of the inner class and passes it to the constructor of the thread class, all at once. So if you have something very, very small to do, and you want it to go on a different thread, you can define a class. You can define methods in the class, make one instance of it, and do something with it all at once. And it's a shortcut. It doesn't do anything that you couldn't have done by making a new class with a name that implements the Runnable interface and overrides the run method. It's just a shortcut. So if you have very simple things to do and you want it to happen on a different thread, this is a way of defining that. Anytime you ever see a close brace inside of a parentheses, it is almost always that you are creating an anonymous inner class and you are passing it to some other method. So we create the class, make an instance of it, and pass that new object to the constructor of the thread class. Let's run that and just make sure that it's working, and it is. It executed on a different thread, but there was no loop, so it just finished and went to the dead state. Okay, so what else should we do in here? Oh, well, here's something that you're not supposed to do anymore. We could say cookie1.suspend. Okay, see this line through the suspend? what we did was we took cookie 1, which was in a ready state or a running state, and we said we are suspending that method. It may not run even one more line. It may not return to the ready state because it is suspended. So cookie 1 was the one that started out "you will always," and that thread is not running anymore. And why does it have this line through it? It is deprecated. So they have decided that suspending and resuming threads, it works, but it's deprecated. That means that we speak ill of it, and you are not supposed to suspend threads and resume them anymore. This is kind of an interesting story. Well, why not? It seems like a powerful thing to do, right? You're not expected to suspend and resume threads anymore because people would use this so much that they got into a lot of trouble. Create a multi-threaded application and then the whole thing just stops. No one knows why. So you start suspending some threads to allow the other threads to run, and then you have to resume them someplace, and it just got to the place where, okay, we can't do that anymore. We can, in only a half an hour, create some code that no one will ever figure out what it's supposed to be doing. And the first person who needs to figure it out is the person who created the mess. So, we don't do suspend and resume anymore. Let's go back to the life cycle diagram and see what we've done. So we know what the born state is. The start method puts us ready to run, and we get dispatched to the processor. We know what the sleep state is. We just call the sleep method, and that thread that executes the sleep method goes into a sleeping state. We know what suspend is, and we know what suspend and resume are, and that we're not going to do them anymore. We know what an I/O request is, and why that would block a particular thread's execution. If the run method finishes, the thread goes to a dead state. You cannot restart a thread. You can make a new object, you can make another instance of that class and start it again, but you can't reuse that object that was created and call it start method again. Once it's dead, it cannot be reused. Okay, so the only things on this diagram that we haven't talked about are wait and notify. Going to a wait state or a waiting state and then being notified by another thread. And that discussion is important, and it's going to be in a different video, I hope. It's quite an advanced topic, so we'll look at an example that uses wait and notify. But it doesn't have to be done right now. The yield method. I kind of forgot about that one. Let's go back and pick up yield. If you're in a running state and you call yield, what does that achieve for you? Well, we don't have really good examples in here for demonstrating what yield does. Yield is a method that exists in the thread class. If you call the yield method, what does that do? So this thread, an instance of fortune cookie, is going to call the yield method. Remember the two scheduling algorithms that we have. One of them includes priority preemption. So suppose you have two threads that have the same priority. Two threads that have a very high priority, the maximum priority. And they're very, very busy. They never go to sleep. They just keep the processor for as long as they can. Well, what would happen? one thread would get the processor and never give it up to the other. This is a situation called starvation. And what we would like to do is to say, well, every once in a while, we will yield the processor. So you yield yourself. If you execute the yield method, the thread that executes the yield method is the thread that says, I would like to leave the running state now. And that allows an equal priority thread to take the processor. In this example, it really isn't necessary, because most of the time these threads are sleeping. And they're going into the sleep state, which gives the other processor, with the other threads, the access to the processor. If you have very high computational threads that do not give up the processor for any reason, in time slicing they would give up the processor because their time slice is up. In priority preemption, they would not ever give up the processor, and that would starve the other threads. So if you have that situation, the advice is to occasionally yield so that a competing thread of equal priority could then get the processor. And how often you choose to yield is up to you as the programmer of that thread. So in the lifecycle diagram, a thread that is in the running state, if it executes the yield method, this is kind of a funny way of putting it, a quantum expiration, it means that the smallest possible amount of time will put it into the ready state. And that means that other threads that are ready could then get the processor. And this yield would allow, in priority preemption would allow threads of equal priority to share the processor. And this is something that well, it's a technique that you would use especially if you want some very busy threads to work in a similar way on time slicing or priority preemption. Okay, we have done almost all of multi-threading. The parts that we haven't done deal with sharing data among independent threads. So if you have multiple flows of control and they're changing data, changing your variable values, how will we deal with that? How will we control that the data that we're using in the variables is current? And that's a little bit tricky. In fact, that might be the most tricky part of multi-threaded programs, and we'll go to there. But not in this video. That's enough for this one.